So we're looking to see if we can figure out which of these equations down here match up with the data that we have. So the first thing we want to do is we want to try and figure out what our slope's going to be. This is an Algebra 1 thing that we should have done before. It may have been a minute. So let's look and see if we can figure out what our slope is. First thing we need to know, they always send an email about their passes. If they don't give you guys passes, they send us an email. I think there were like 4 late buses. Yeah, there were 4 late buses today, which is why they weren't giving you guys passes. Gotcha. All right, so we have some information up here. We've got some year, we've got some population, that kind of jazz. Which one of those is going to be my x if we're looking at year and population? Which one of these is x? Which one of these is y? If we have a unit of time, it's always going to be your x. Every time. If you have a unit of time, that is going to be your x. Because if I make people move to my town, it does not make time go faster. If people run away screaming from my town, it does not make time go slower. I cannot control time by changing my population. Time changes my population does not change time. It'd be cool, but it doesn't work. So if you have a unit of time, that is your x. Weeks, days, years, months, seconds, I don't care what kind of time it is, that's your x. So process of elimination means population is going to be my y. So we want to know, so that we can kind of look at these equations down here, what our m is. We're trying to find our slope. How can I find my m if I'm looking at a table with x's and y's? How do we remember slope again? Rise over run, that kind of guy. I'm gonna make these thicker because these are really skinny. Well, if we think rise, that's how far up or down we go. So that's how my y's are changing. What happens with 862 to 846? What kind of change is that? Does it go up or does it go down? It goes down. So we're going to have a negative number. By how many? What is 862 minus 846? 16. So my y's go down 16. They are decreasing. How did my x's change? They went up 10. So my y's went down 16, my x's increased, they ran 10 to the right. So I could simplify that. What is negative 16 divided by 10? Negative 1.6. So if we look at our equation options down here, I have 2 I can instantly rule out. Which one of these are definitely not our equation? B and C. They both had a slope of 16. The last part on this one, because this is an SAT prep question, takes a little bit of logic to figure out between these 2 pieces here. So this part, 100%, something we can do. From here, it's all a matter of like now we're Englishing our math problem, and it's a little gross. Because what they want us to do is they want us to be able to put in T, not the whole year, not that it's 2010, not that it's 2025, but that it's 10 years after 2000 or it's 20 years after 2000. So we're just going to be able to put some number here, not looking at the difference with the year 2000. The phrase that tells us this is that t years after 2000 means we just want to have t. If I have that it's 10 years after 2000 and I take away 2000, that is going to be a massive number and negative and gross. So if you get to something like this on like SAT or PSAT, a good option is, well, I've narrowed it down to 2. How can I substitute in? For t years after 2000, I could put in a 10 and try to get an answer of 846. I could put in an answer of 0 and see if I get 862. This one would give me wrong answers. If we can find our slope, it makes it so I don't have to guess and check on all 4 equations. I get to eliminate out 2 of them. I don't have to look at these 2. They have the wrong slope. They're not going to be the answer. These 2 both have the right slope. So what we can do is we can do a guess and check, but only on 2 equations. So when we have SAT questions that are weird, use what we can, and then it's multiple choice. Use some guess and check stuff. It's okay strategy to use. It's a valid strategy. But this comes from the SAT question bank. That's why it's weird. And we're going, what? SAT loves to write questions that make us go, what? This is one of them. Okay, so it's awkward and weird. We're going to talk a lot about slope today. So it's kind of getting us to remember that. We have used slope before. We've talked about it before. But it's been a minute. So we're going to talk about it a bunch today. Questions on this one? Just to be clear, the answer on this one is A. But it's kind of just an awkward way to get there. No. Okay. We're going to move on from that because, again, SAT Pro questions are weird and awkward and gross. They take practice because they love to ask things in bizarre ways. They do too much, a lot of times. So today we're going to work with something called our point slope form. We talked about that a little bit yesterday when we wrote down all our different kinds of equations that we have here. And point slope form is a very special kind of equation because we just have to like plug pieces in and then stop touching it. It's a lot of substitution. And this definition is straight up copied from your book. It's that same formula we wrote down yesterday, right here. Our y minus y1 equals m parentheses x minus x1. And what that is telling us is that if I have a point, we call that one x1, y1. And if I substitute those 2 pieces in here with m, our slope, I have an equation that goes through a point at a slope. So we're going to be able to do this very much like a substitution. I've got our formula up at the top up here. And it talks about example 5. Now, a lot of it's written there for you. I'm going to show you what this is because it's one of those things that it's really awkward the first couple of times, but once we get the hang of it, it's not awful. So we're going to take our equation, our y minus y1 equals mx minus x1. The x and y that don't have the little numbers will be in our equation. Just like we have our y equals mx plus b stuff, and we get like y equals 2x plus 4. There's a y and an x still there. In point slope form, there's going to be a y and an x still there, and it's the ones that don't have the little bitty numbers. So when we are given a point, this 3, -5, this is my x1, y1. So my x, whoa, that's not the header, my x1 is the 3. And my y1 is this 5. So in my equation, I can substitute those pieces in. My y1 goes over here, and my x1 goes over here. The other piece we need to include is we need to include the m. We have a slope of 11. That guy's my m. So when we go to fill in this equation here, what we're going to have is our y minus our y1, the y value from our point, which was that -5. And that's going to equal our m goes here. That's my 11. And then in my parentheses, we have our x minus my x value from the point, which is a 3. I've substituted all my pieces in. And if it helps, substitute this in parentheses. Because we have one thing we need to simplify on here. We're not going to like try and fully distribute, get this around in a slope-intercept form right here. The one thing we need to simplify is I have a minus negative. We don't like to have signs next to each other. Even though it's inside parentheses, it's still kind of icky. So if I want to subtract a negative number, y minus -5, that's the same thing as y plus 5. Equals our 11 times x minus 3. That is our equation in point-slope form. This is our answer. And in fact, that exactly matches the one that the book walked you through, or the notes packet walked you through over there. So we're going to find our x1 and our y1. We're going to find our slope, and we're going to substitute those in. So let's look down at the bottom. Same vibe. We're given a slope, and we're given a point. So we have a slope of 4, and it goes through the point -5, 7. So on this one, we know our m, our slope, is going to be 4. And our point, this -5, 7, that tells me my x1, comma, y1. This is my whole point right here. So in our formula, we can substitute those pieces in. So our y, we're always going to leave the one that doesn't have the little number there, minus the y value from my point, 7. That's this guy. And that's going to equal our slope, 4, times x minus our x value from our point, -5. X minus -5. And you can set it up just like this. You can put the parentheses around our x if that helps you, because we need to simplify. We've got these double signs going on here, and that's not okay. We got to fix that. So our equation is going to be our y minus 7 equals 4 times, not x minus -5, but instead x plus 5. Minus -5, that's the same thing as plus. Okay, questions on that one? No, we've done 2 of them. Same vibe for B. Very similar vibe. So on this one, what is our m? -1/2. That's our slope. What is our x1? x1 is 2. That's this guy right here. And our y1 is what? -8. So it's playing match them up. You can write it in whatever style works for you. You can circle stuff, you can highlight it, you can label things. We can plow through. I'm just going to rewrite that 2 because that one looks very much like a Z. There we go. Now it looks like a 2. So you can label stuff, you can circle stuff, you can highlight stuff, however it works for you to keep track of things. If you ever need colors, let me know. I have markers, colored pencils, highlighters out the wazoo. I can get you whatever you need. And then we're going to just substitute things in to get our formula. So we're going to have our y minus our y1, so y minus -8. And that's going to equal our m, which is our -1/2. Then we have x minus x1, so x minus 2. And I tend to substitute values in the parentheses simply because it makes keeping track of signs easier. You don't have to include the parentheses. And you can also, once you get the hang of it, you can do the simplification here in the first step. That's totally fine. You don't have to do this in 2 steps. We do need to make sure we get our signs correct though. Because what is this going to be over here? It's not y minus -8. What am I going to put? Plus. Minus negative is the same thing as plus. Our -1/2 is still going to stay. That's not changing anything. And our x minus +2, that's just exactly what it is. So that's our equation there. That goes through the point to -8 and has a slope at -1/2. So point slope form is very, very just plug and chug. Not very super math heavy. But we don't always just straight up hand you a slope. Sometimes we'll have to figure out our slope, and we have to remember how to do that. No, wait, what? We did that in the bell work. Oh my gosh, relevance, what? So there is a formula for how we found our slope, and the way we remembered how to do it in the bell work, 100% is this formula. We just talked about it using words instead of a formula with little baby numbers. And the formula up here is absolutely microscopic. Holy cow. It's in your books. It's on the next page. I'm just going to rewrite this thing because holy cow is that thing tiny. So you guys have it written in your books. It's kind of off to the side. I'll put it over here. M equals. And this one says y2 minus y1 over x2 minus x1. Well, we were just working with y1 and x1 in our point slope form. Now we have y2 and x2. All that is we've decided, okay, we've got 2 points here. I don't want to have to talk about the point on the left and the point on the right. I'm going to name one of them point number 1. And I'm going to name one of them point number 2. So I'll go ahead and say that this one on the left, this guy is point number 1. So that means these pieces are going to be my x1 and my y1. So that means I'm going to decide to call this point here point number 2. This guy would then be my x2 and my y2. They can be named any number, letter, whatever you want. It's just instead of me going, okay, the point that's on the left and the point that's on the right. Point 1, point 2, point A, point B. It doesn't really matter. And it doesn't matter which one I call 1 and which one I call 2. We will get the same answer either way. It genuinely does not matter. And if you don't believe me, test me on it. Switch it. Do yours with 2 and 1 switched. And all it is then I'm going to take these values and substitute them in. Super duper important thing. The 2's stay together in a column. The 1's stay together in a column. No mixing and matching. I cannot flip these if I like one of them different. So when we set this up, when we're trying to find our slope that goes through these two lines, or these through points, we're going to set it up as a fraction. So I'm going to take my y's. I'm going to have my 13. And then I'm going to subtract y1. 1. So I'm straight up setting up my y from point 2 and my y from point 1. My numerator contains my y's. Rise y's. And then the denominators, we got to remember to run from the x. Don't go back with the x. Run from the x. Red flags are there for a reason. So our x's are on the bottom. And I have my x2 take away my x1. So we set it up like this, and then we can simplify each of these pieces individually. What is 13 minus 1? 12. What is 7 minus 1? 6. I ask super hard questions sometimes. Okay. What's 12 divided by 6? 2. So our slope here is 2. So we set up our subtractions. We're finding the change in y's. We're finding how much it moved up or down. We're finding how much it moved left or right, the horizontal shift, our rise over run. Y's rise, run from your x. Run is x. So rise over run, rise is y's, run from the x. Okay? From there, now I could write an equation in point slope form. I've got 2 points. Pick one. So we now know our slope, and I know 2 points, so we just need to pick which one to do. And I can use either point. I could set this up with my point number 1. So we'd have our y minus the y from my point, which was 1, equals our slope, m, which was 2, x minus x1 from my point. So that 1. That is an equation in point slope form with the slope going through that point, 1, 1. It will also go through the point 7, 13, and you could plot that up if you want to check it. I can write another equation here, though, without having to do any further math, because I don't have to use point 1. I could also do point 2. Another equation for this line is my y minus y2. So my 13 equals our same slope, 2 times x minus 7. We can absolutely write more than one equation for this line. I could plot up these points. I could see that this line is going to go through both of them. It does not matter which equation we do. We can use point 1, we can use point 2. It doesn't matter if I call this one point 1 or this one point 1. It doesn't matter. I can use either one. So we're going to practice this a couple more times. But questions on this first one? I'm going to kind of go through all of it. Okay, so here's part A, and I know there's not super tons of space right there. If you need to use some of the example portions, that's okay. There we go. All right, so we want to find the slope, and we want to write an equation in point slope form that goes through these 2 points. So we need to find our slope, and then we're going to write an equation. We are going to name these points. It does not matter which one we name what, but we need to name one of them point 1 and one of them point 2. I have a tendency to say, okay, whatever this first one is, that's going to be point number 1. And the second one, I'll have be point number 2. It genuinely does not matter, though. So that makes this my x1 and my y1. And if it helps you, write this out every time. I often do. It just helps me keep track because I have a tendency to forget stuff. And I don't want to have to rethink it. If we label things, all that's doing is helping you from forgetting. It is okay to label stuff. You don't have to do things super fancy and bougie and weird. So our next thing we need to do is we need to find that slope. So we want to find our slope. That's going to be our m. And we can always remember that our slope is rise over run. We rise with y's, so we're going to look at our y's. I'm going to take my y1, 5. Oh, sorry, we do y2 minus y1. I'm going to take my y of 0 minus my y of 5. My run, we got to run from the x's. So we're going to have our -2 minus -5. If you do set it up with x1 and y1, or x1 minus y1 and y1 minus y2, wording again. If you set it up with x1 minus y1, y1 minus y2, there we go. Braining is fun times in the morning. If you flip these, as long as you flip both, it genuinely does not matter. If you put it as y1, y2, x1, x2. As long as your 2's are stacked in a column and your 1's are stacked in a column. I just set it up this way so that it matched up, but it genuinely does not matter. You will get the exact same thing. But I know we like to follow the formulas and stuff and follow the rules. What is 0 minus 5? -5. And then we have -2 minus -5. And you can type it in the calculator. Ooh, good call. That is 100% my brain not braining. That x1 is supposed to be my -7. You're exactly right. Exactly right. I was going to be like, ooh, that was weird. -2 minus -7, which is -2 plus 7, which gives us what? 5. Good call. 100% call me out on that. That's called coffee hasn't kicked in. Hold, please. There we go. Little caffeine boost. Gotta get that going. Yeah, 100%. If you ever see me write something like that, please call me out on it. 100%. I make mistakes. Any teacher who says they don't is lying. We are humans. So we can simplify that. What is -5 divided by 5? -1. So now I know my slope. I know a couple of points. I can get myself an equation. So we do want to write an equation for it, and we could write either equation. We can use x1, y1. We can use x2, y2. It doesn't matter. I'm going to write both because I'm extra like that. Shock, right? I know. Oh, my gosh. So we're going to have our y minus, and I'm going to use 0.1 first just because that's the one in the formula. So I'm going to have my y minus my y1, which was 5. And that's going to equal our slope of m, which was our -1. And then we get our x minus our x1 minus -5. Minus a negative becomes plus 7. And I did it with blended colors there so we can kind of see what's happening. This is a plus 7. There we go. So you can do the simplification with the signs without needing to do the whole line twice. Or you can write it straight out and then simplify. I'm also going to write it with the other point just so we can see that one as well. Our y minus the y's over here from y2, that is 0, equals our -1 times our x minus x2, which is our negative 2. So minus negative 2 becomes plus 2. You can write either one of those equations. We don't have to simplify right here. We could. This is about a step away from our slope-intercept form because we have y minus 0. All we would need to do is distribute the right side, and we're at slope-intercept form because we would have our y by itself. Questions on this one? Because we did a lot on here. We only have one more that we're going to do today. And that's B. And again, I know we have a very small amount of space on the page. I'm sorry about that. But we're going to do this exact same thing. We're going to make this be our points 1 and points 2. Just for funsies, I'm going to switch it. I'm going to say maybe this guy's point 2 this time, and maybe this guy's point 1. It genuinely does not matter which one you name which. I like to label things just because it helps me keep organized. So this is going to be my x2 and my y2. I mean, you saw how well my labels helped last time. So x1 and y1. Labeling things never hurts. It can only help. Tries to help us keep organized and not lose track of stuff. But brains like to make fun choices sometimes, and so that's okay. Mistakes happen. So then we're going to find our slope. We can take our y2 minus y1. We can take our y1 minus y2. It doesn't matter as long as we don't mix and match. So I'll just do my y2 minus y1 as we have it in the formula. So that's going to give me my negative 6 minus my y1, which is 3. I'm going to write the bottom wrong so that we can see what I mean when I keep saying don't mix and match. So I'm going to say do not do 1 minus negative 4. See how my point 2's are not lined up? My point 1's are not lined up? This is wrong. As long as I have them matching, it doesn't matter which one I have in front. But I cannot crisscross. So I cannot do the 1 minus the negative 4. I have to match the top how it did it. So the pink point for me is on the left, my negative 4. My blue point for me is on the right. They have to match up. I have to have, so point 2 is pink, so I have to have pink. They have to match up. And if you want to use colors for that, 100%, I have colors. Colored pencils, markers, highlighters, anything. Then we need to simplify this. What is negative 6 minus 3? Negative 9. What is negative 4 minus 1? Careful. You may have said it, I just didn't hear it. Negative 5. I just didn't hear the negative. Does that simplify? Negative 9 over negative 5? I mean, a little. What happens when I try and simplify that? It's like you can type it in the calculator, negative 9 over negative 5. The negative signs cancel out. We get a positive 9/5. It's not super pleasant. And you could put it as a decimal. It's going to be 1.8. But if we're thinking about this being slope, fractions are actually easier to work with. So I recommend just leaving it as a fraction. It's not wrong if you put it as a decimal. You can put it as 1.8. It's fine. It's just way harder to graph. And then all we got to do is substitute our pieces into our equations. So we're going to have our y minus, and again, I'll do my y1 first. It's my blue point over here. Y minus 3 equals Rm, that 9/5 9/5 x minus my x1. 1. I have an equation. I could do the same thing with the other point. You don't have to use both points, but I can use either one. It genuinely does not matter if I do my y minus 3 or if I do my y minus -6. Y minus -6 becomes plus 6. Then we have our 9/5 x minus my x2. So it's going to be minus -4, which becomes plus 4. And again, if you do that in 2 steps to simplify your signs, that's totally okay. Totally valid. Either one of those equations is fine. I just like to write both, so in case somebody picked a different point, we wind up with both of them. Okay, questions on these? Okay. So that is honestly mostly what's on the back of homework 3. Homework 3 is due tomorrow. We're also going to do a skills check tomorrow. It's not super long, it's not super bad. But just kind of check in where we are in this first half of the chapter, because next week we're going to start looking at more than one thing at the same time. So make sure you guys are doing those Canvas assignments. It is the easiest set of points possible. Like, they're for completion. Just try. They do close after 2 weeks, though, so make sure you're, getting to them. Don't save them all for the end of the semester because they close. Also, I have on my wall over there 3 algebra assignments that have been turned in, completed, with points, and no name. So if you've done something, and as of 2 days ago, had it turned in, and have no grade for it, check the wall. I do have a stack of stuff from you guys from yesterday that I haven't got through yet. I'll get to that today. So there may be more things up there tomorrow. But please make sure you're checking stuff. I'm going to work to get things passed back to you guys. Hopefully I'll get some back before we get announcements done, and then I'll work on getting stuff back to you guys tomorrow too. But please make sure you're checking your grade. If you know you did something and you don't have a grade for it, check up there.